Fewer applicants, making LPG a strong component for the national adoption. I am wondering why, when we started, you know, having the automobile factories in Ghana, we did not ask them to produce gas engines because we haven't yet uh, gotten grasp of the uh, electric vehicles. And I think as an oil producing company, that would have been a brilliant idea. The second study presented at ASME Internal Combustion Engine Conference in San Antonio, USA, focused on fuel adaptation through sampling and stakeholders interviews in Tema. We undiscovered widespread use of naphtha and kerosene as the adulterants. Experiments at Tema Oil Foundry confirmed the focused on fuel adaptation. It's through sampling and stakeholders interviews in Tema, and it brings about high widespread use of naphtha and kerosene as the adulterants. Experiments at Tema Oil Foundry collaboration goes on fuel adaptation. It's through sampling and stakeholders we set out to optimize lubricant brings about widespread centralized and kerosene in systems for experiments at Tema Oil Foundry. Collaboration makeshift methods serve their purpose. They often led to issues like misplacement of kata and injuries and occasional valve burning. This observation motivated the development of the Foundry systems makeshift chemical engineering workshop, serve providing a safer and more precise solution. I have played a pivotal role under the auspices of Petroleum Commission injuries in formulating Ghana's national and occasional valve ban, a key milestone and more in professionalizing the world in the industry and strengthening the local pivotal role under the auspices of Petroleum Commission. Also played in formulating Ghana's national and occasional valve ban, a key milestone contracted by professionalizing the world in the industry and strengthening the local pivotal role under the auspices of Petroleum Commission. Also played in formulating Ghana's national and occasional valve ban, a key milestone contracted by professionalizing the world in the industry area and strengthening the local pivotal role under the auspices of Petroleum Commission. Also played in formulating Ghana's national and occasional valve ban, a key milestone contracted by professionalizing the world in the industry and strengthening the local pivotal role under the auspices of Petroleum also played formulating Ghana's structural whether by professionalizing the world in the area and strengthening the local also played formulating Ghana's structural whether by professionalizing the world in the area and strengthening the the successful reactivation of the plant, and it has remained operational ever since. Prof. Chair, distinguished guests, a critical assessment of Ghana's mechanical engineering curriculum and its graduates reveal persistent gaps in design, analysis, instrumentation, and metrology. These gaps hinder their ability to meet evolving industrial demands and drive innovation. Again, the challenges are compounded by limited access to internships, inadequate laboratories, and technical training, and disconnect between academic content and real world application. As the fifth industrial revolution builds upon the fourth, with a renewed emphasis on human machine collaboration, ethics, inclusion, and sustainability, our future engineers must be equipped with skills in 5G connectivity, renewable energies, smart grids, and advanced materials. Through my work spanning braking systems, thermal efficiency, fuel quality, sustainable components, solar microgrids, and predictive maintenance, along my endeavors and daily experiences as an engineer, educator, administrator, leader, and concerned citizen, I have come to appreciate the transformative power of collaboration, mentorship, and applied research in driving progress. It is from this conviction that I introduce Gonsom, the hexagonal partnership model, the framework designed to foster future-ready mechanical engineers through shared learning, institutional synergy, and strategic innovation. Together, we can reposition Ghana's engineering education thrive in the era of the fifth industrial revolution and beyond. Distinguished guests, esteemed colleagues, future leaders, ladies and gentlemen. When I was a young science student, the use of calculators during examination was a taboo. Instead, we relied on the intricate dance of slide rules and the precision of four-figure tables to carry out our computations. And I know that those of you who are, I think, 50 years and upwards, really appreciate that. And Professor Dankwa would bear me out because GSTS will lie back. They won't allow you. Today, I hold in my hands devices such as smartphones, smartwatches, each boasting more computing power than the room-sized computers of yesteryears. These devices connect me to a universe of information and allow me to control machines remotely, as the registrar used to do when he sits here and then he controls affairs at his hometown. Bridging the gap between physical and digital in ways we once only dreamed. We encounter these wonders daily. A car moving at a speed momentarily brakes and alert the driver to an approaching object. A spacecraft precisely lands its first stage booster at a designated site on land or at sea. Medical devices like pacemakers and insulation pumps, now part of cyber physical systems, continuously monitor vital signs and automatically adjust and deliver treatment as needed. Ladies and gentlemen, this is not science fiction. This is the reality of the fourth industrial revolution. Transformation that is shaping mechanical engineering, the discipline that has long molded our physical world in ways once unimaginable. The fourth industrial revolution, as defined by Chiwa in 2017, fundamentally has changed the way we live, work, and interact. These days, you take your family out, and as you sit on the table, you give them the menu, you think you converse and select what you want to eat. Nobody will mind you. Everyone will be engaging with his or her computer. But when you ask them, Are we not conversing? We are chatting. Build on the foundations of digital revolution. It is crystallized by technologies that blur the boundaries between physical, digital, and biological realm. Its key pillars include interconnectedness, where we seemingly connect devices and systems, automation, digital exchange, and advanced technologies like AI, robotics, Internet of Things, 3D printing, and cloud computing. Prof. Chair, mechanical engineers are vital to this revolution. Their core strength in design, analysis, and manufacturing, coupled with an embrace of new technologies, positioning them as center figures in the march of progress. Historically, mechanical engineers have been masterful work. They create objects, they deal with forces and systems. Their knowledge of mechanics, material science, thermodynamics, production, reliability engineering allows them to design and build machines from engines to life-saving medical tools. To analyze and optimize systems to function under real-world stresses and to manufacture high-quality products that meet standards. These competencies remain essential, but the fourth industrial revolution demands more. Integrating emerging technologies is now key to drive efficiency, connectivity, and sustainability. This, ladies and gentlemen, has shaped the roles of mechanical engineering into areas such as cyber, physical systems like autonomous vehicles, smart buildings, and robotic systems, building physical and digital realm. Advanced manufacturing, robotics and automation, artificial intelligence and machine learning, where we leverage on the AI to better design and predict uh, occurrences of maintenance and produce optimization. We also have IoT, where we have embedding of sensors and analytics into products. And then we also have blockchain. Mr. Chairman, the fourth industrial revolution, despite its technological strides, often prioritize efficiency over ethics, replacing rather than empowering workers and sidelining sustainability and human creativity. Smart machines emerged, yet they lack empathy and adaptability, exposing the limits of purely tech-driven approach. The fifth industrial revolution seeks to redress this, emphasizing human machine collaboration, ethical innovation, inclusion, and sustainability. Engineers of the future must lead in AI, IoT integration, digital twins, renewable energy systems, and 5G enabled smart infrastructure. Factories must not only be smart, but ethical, aligned with human values and the UN's Sustainable Development Goals, particularly SDG 4, that is quality education, 7, that is affordable and clean energy, and 9, industry, innovation, and infrastructure. Prof. Chair, as Aristotle reminds us, and I quote, educating the mind without educating the heart is no education at all, unquote. And in this new era, education must be both technologically rigorous and ethically grounded, serving all of society and not just a privileged few. But Are we truly preparing our students for this future? This is a question I would want us to ponder over. I need no questions. I need no answers here now. Are we preparing our students for this future? Prof. Chair, complacency is not an option. We must move beyond outdated pedagogies and create dynamic, engaging environment tailored for the Generation Z. Digital natives who learn visually and collaboratively and experiential. As Mark McGregor 2016 observed, and I quote, if they don't learn the way we teach, then let us teach the way they learn, unquote. The Gen Zs learn differently. They are post-linear. They learn through experience, not just structure. They are post-literate, communicating through images and videos, not just text. They are post-logical, valuing creativity and emotional connection over rigid rules. They are the digital natives who thrive in a world where information is instantly accessible. Ladies and gentlemen, education must evolve, not just to prepare students for the digital world, but to empower them to shape the world. The knowledge that brought us here cannot take us beyond where we stand today. That is why my vision and the theme of this lecture is clear. Cultivate a generation of future ready mechanical engineers in Ghana for the challenges of the fifth industrial revolution and beyond. This vision is anchored in Wonsom, a clear call for collective action through the hexagonal partnership imperative. Ladies and gentlemen, recognizing the global shift brought by the fourth and fifth industrial revolutions, it becomes imperative to examine the preparedness of future mechanical engineers within our national context. To that effect, this study was undertaken to analyze the current BSc mechanical engineering curricula across both public and private universities in Ghana. The central aim was to assess the degree to which the curricula addressed the crucial competencies deemed necessary for mechanical engineering graduates to efficiently navigate and contribute to the evolving demands of the fifth industrial revolution. Four fundamental areas were identified as critical for the success in this transformative plan. They are the technical competencies, the methodological competency, social competencies, and personal competencies. Prof. Chair, under the technical competency, we realize strong competencies include mechanics, solid mechanics, thermal science, and electrical systems, indicating a solid theoretical foundation in core mechanical principles. We had proficient competency in metallurgy, material science, and manufacturing, reflecting adequate knowledge with generally effective application, though complex tasks may require support. And there was a developing competency realized in design and analysis, suggesting a basic gap with a need for more exposure to advanced tools like FEA, CFD, and CAD with guided supervision. The recommendations are that one, we should adopt advanced practical expertise in smart manufacturing. We should expand hands-on training in CNC machine and 3D printing and industrial automation. We need to strengthen academia industrial collaboration, embed advanced manufacturing in curriculum, integrate emerging materials and applications, enhance digital design and simulation, build proficiency in CAD, CAE platforms such as SolidWorks and ANSYS to support agile printing and visual testing. Under methodological competency, we had strong competency in mathematical and computational analysis, reflecting strong skills in problem solving and numerical simulation and optimization. We had developing competency in mechanical designs and analysis, indicating basic design ability but limited experience with advanced tools like FEA, C, FD, and POP. And there was a basic competency in instrumentation metrology, highlighting a gap in experimental methods, measurement accuracy, and data validation. The recommendations are increased focus on precision engineering and training to improve experimental analysis skills. Introduce industry standard software such as MATLAB, ANSYS, SolidWorks in design courses to enhance digital design and simulation capacity. Emphasize hands-on on instrumentation labs and research-based learning. Establish industrial academic research collaborations to work on applied projects. Host problem-solving hackathon for engineering design challenges. Conduct regular workshops on AI and ML in mechanical engineering to bridge theory and application. Professor Chair, under the social competencies, we realize that there is proficient competency in mechanical design and analysis, which supports efficient teamwork through clear design, communication, and task coordination. And there was a basic competency in engineering management and economics, indicating gaps in leadership and project management skills, potentially limiting contribution to team-based initiative. The recommendations are to integrate joint projects and communications to help mechanical engineers collaborate with their peers from computer science, electrical engineering, and business studies. And to emphasize the importance of clear communication and share understanding across diverse technological domains. Under the personal competency, we realize that there is a proficient competency in general studies, reflecting broad interdisciplinary exposure, supporting adaptability, self-learning, and professionalism through enhanced critical thinking and communication skills. The recommendations are to encourage participation in professional development programs through conferences, industrial seminars, and online certification. Provide real-world case study on engineering, economics, and entrepreneurship. Develop self-learning strategies through online courses and industrial-led workshops. To introduce mentorship programs where students are paired with industrial professionals like engineer Edwin. Encourage participation in engineering competitions and innovation challenges. Establish student-led research groups and incorporate activities that require students to adopt new technologies, methodologies, and problem-solving approaches. Distinguished guests, ladies and gentlemen, to gain deeper insight into the gaps identified through the curriculum assessment, feedback was solicited from mechanical engineering graduates based on their experiences in the program. 4 core issues came up: internship and industry access, clinical and laboratory limitations, instructor and curriculum gaps, and research exposure. Internship and industry access, Prof. Chair, emerged as the most significant concern. And here we had 5 points that came up: limited internship slots from companies, high competition from students from different institutions, slow or no response from organizations, logistical barriers such as distance, transport, and accommodation, inadequate preparation for aptitude tests required by companies. And practical and laboratory limitations, we had insufficient laboratory equipment and research setups, inadequate opportunities to connect theory with practice, limited access to demonstration tools and hands-on learning. Then under the instructor and curriculum gaps, Prof. Chair, we had these issues: lack of instructors with real-world industry experience, inadequate design-based and critical thinking project, poor integration of coding and simulation tools like MATLAB across core courses, and under research exposure, undergraduate students rarely participate in research projects and academic publishing. Mr. Chairman, ladies and gentlemen, the fifth industrial revolution is not only merely about combining existing technologies, it also ushering in entirely new frontiers within mechanical engineering. And as Max Ellman wrote in his timeless 2017 prose poem, he's a director, and I quote, "Keep interested in your own career, however humble. It is a rare possession in changing fortunes of time," I unquote. This message resonates deeply in today's rapidly shifting world. Mechanical engineers must remain heroes, grounded and purpose driven. The future will be shaped not only by technical expertise, but by courage to adapt and then the vision to lead meaningful change. Here are some of the most exciting and rapid expanding fields: mechatronics and robotics, smart materials and adaptive structures, bio-inspired engineering, sustainable engineering and renewable energy, 3D printing, advanced manufacturing, micro and nano engineering, computational engineering, and data science. Mr. Chairman, ladies and gentlemen, addressing these challenges and seizing emerging opportunities required a unified and sustained effort from all stakeholders. This is the essence of our hexagonal partnership imperative, anchored in the spirit of Wonsom Wonsom. Wonsom Wonsom translates to all hands on deck, a powerful call to collective action where everyone moves forward as one. Yet, it also embraces the deeper spirit of let's lift each other up, reminding us that the transformation is not only meaningful when it's only meaningful when it is inclusive and collaborative. Our 6 pillars of partnership: academia, industry, government, professional bodies, communities, and students must work in harmony, contributing their unique strengths to build a future-ready, human-centered mechanical engineering ecosystem. First pillar I want to talk about is academia. If Ghana is to seize opportunities of the fifth industrial revolution. Our academic institutions must reimagine as engines of innovation and human-centered progress. This transformation calls for bold actions across curriculum, faculty, research, and student development. Here is what must be done. One, modernize curriculum for 5IR, that is fifth industrial revolution realities. We must, we need to embed the core 5IR technologies such as robotics, AI, advanced analytics, additive manufacturing, Internet of Things, digital twins, and sustainable design directly into our programs. These technologies must be taught through hands-on problem solving experiences that mirror the real world. Two, we must empower educators through practice driven development. Our lecturers are key to preparing students for industry that evolves daily. Targeted upscaling, faculty exchange, and immersion in real world projects must become standard practice. As Professor Vladimir Litvinenkov wisely cautioned, and I quote, placing a professor without industrial experience in charge, preparing students for industry often leads to a disconnect between academic training and real world expectation. I unquote. We must bridge that divide. We need to align research with Ghana's industrial needs. We need to expand practical and immersive learning opportunities. We need to build fluency in technical and digital tools. In fact, to compete globally, our students must master tools like MATLAB, SolidWorks, Princess, COMSOL, Abacus, alongside hands-on on CNC machining, 3D printing, and automation. We need to nurture methodological and analytical thinking. We need to foster leadership, soft skills, and cross-disciplinary collaboration. We need to spark entrepreneurship thinking and innovation culture through spring design to hackathon. We need to champion lifelong and self-directed learning through online certification, micro courses, global conferences. And finally, we need to forge through academia industry partnership. The second pillar here is industry. Industry must provide practical experience to bridge hands-on, to bridge the hands-on on skills gap. We must establish strong collaboration and core programs, industrial sponsored projects, and immersive site visits. We need to have collaboration on curriculum. We need to invest in education. Companies must become strategic partners in retooling universities for the 5R pillar, not through philanthropy, but it's a high return investment. This includes modernizing our laboratories, sponsoring research chairs, providing software, and sharing expertise. Industry should offer hands-on exposure to diagnostics, servicing protocols, and equipment life cycle. The third pillar, Prof. Chair, is government. Government must formulate policies and funding. And government should ensure that we have equitable teacher-student ratios and a competitive faculty remuneration. I say this because I'm a unionist and I always remain a unionist. Our teachers are dying because of the load. Government should launch national skill development programs Government should prioritize investment in digital, energy, and transportation infrastructure and establish modern laboratories. The fourth pillar, Prof. Chair, is professional bodies. Our professional bodies must set standards by strengthening university collaborations for curriculum alignment and expanding continuing professional development. They must foster collaboration and they must promote diversity. The fifth pillar is our community, the root of future talents. Prof. Chair, the role of our communities is often overlooked but profoundly valuable. They must foster early interest, organize STEM outreach programs, maker space for younger people. They should support long life learning, provide accessible vocational training, and promote online learning platform to upskill and reskill workforce. They should bridge the digital divide and they should address local needs by collaborating with all stakeholders to develop tailored, sustainable, and socially impactful fifth industrial revolution solutions. And lastly, the sixth pillar is our students. The ultimate success rests on the shoulders of our students and future innovators. They are not passive recipients, but active agents of change. They must embrace lifelong learning, recognize that learning is continuous, actively seeking out for internships, workshops, online courses, and self-directed learning opportunities to stay ahead. I must tell you this, though I had PhD all right, there was the need for me to go for the NDT certificates. And I tell you, that in the doors for me to do some of the audit works that have been demonstrated. So we need to always seek to improve ourselves and be abreast of time. Students should cultivate adaptability, human centric softwares, and develop strong critical thinking. And they should proactively engage with each other through research projects, building professional network, and seeking mentorship. And they should act ethically. They should act ethically. Acting ethically within the scientific and tech field, and again, going away from the winning word. Mr. Chairman, ladies and gentlemen, while the challenges are real, the opportunities before Ghana are even greater. The fifth industrial revolution offers a transformative for key sectors, mining and oil and gas, manufacturing, agriculture, and energy through smart automation, data-driven technologies, renewables, and advanced manufacturing. This wave of innovation holds vast potential for entrepreneurship, job creation, and locally tailored solutions that strengthen our economy. As we advance technologically, we must also lead ethically. Responsible automation, data privacy, environmental sustainability, and fairness in AI must guide our progress. Technology must serve people and planet, not the other way around. Prof. Chair, ultimately, the fifth industrial revolution is not just about machines and systems. It is about human-centered progress. It calls on us to build a future that is not only more connected and intelligent, but also inclusive, ethical, and resilient for all. Mr. Chairman, Nananom, distinguished guests, fellow colleagues, as we bring conclusion to this lecture, let us reflect on the journey we have taken from the formative promise of fifth industrial revolution and the urgent need to close Ghana's mechanical engineering skills gap to the potential of strategic collaboration through the hexagonal partnership model. My final message is a clear and urgent call. We must make a bold, unified, and ethical grounded commitment to reimagining mechanical engineering education and practice in Ghana, to prepare our graduates not just to adapt to, but to lead in the fifth industrial revolution era. We must act decisively. And this includes reforming curriculum to integrate hands-on learning and cutting-edge 5R technologies such as AI, IoT, digital twins, and smart manufacturing. Building strong industry academia partnership for mentorship, practical experience, and collaborative innovation. Cultivating essential fifth industrial revolution competencies, that is digital literacy, adaptability, critical thinking, creativity, and complex problem solving. Modernizing laboratories and creating dedicated future ready workshops. If you move along Ghana and look at our workshops, strengthening, you will cry, strengthening focus on maintenance, repair, and vital, which are vital to strengthening industrial systems. We need to embed in soft skills such as communication, teamwork, leadership, and resilience to empower engineers in dynamic, human-centered ecosystems, fostering interdisciplinary thinking and systems approach to match the integrated nature of the 5R technologies, promoting entrepreneurship, development through mentorship, investment, and applied innovation, driving inclusive policy reform, government investment, and national skills development strategies, expanding equity, access across gender, region, and social economic background. And most importantly, Mr. Chairman, in our context here in Ghana, this transformation must be coupled with a foundational commitment to ICT education from basic to secondary school levels as core subject, ensuring digital readiness begins early and inclusively. Our advancement must also be guided by a strong ethic compass, addressing responsible automation, data privacy, sustainability, biases in AI and manufacturing systems. And we must not overlook the essential infrastructure, stable electricity, reliable internet connectivity, and modern learning environment to support this transformation. Ladies and gentlemen, despite the challenges, I remain deeply optimistic. Ghana mechanical engineers are well positioned to lead our industrial transformation through smart systems, clean energy, advanced manufacturing, and data driven innovation. With the right investment in skills, ethics, and digital inclusion, Ghana can emerge as a regional beacon of sustainability, inclusive progress, where the vision of a vibrant 24-hour economy becomes a tangible driver of the Ghana Beyond Aid agenda. As an engineer, educator, and a citizen, I stand ready to help lead this charge. The future will not build itself. It requires collective resolve across government, academia, industry, communities, and every learner. Let us seize this moment with clarity, courage, and shared purpose because the future of Ghana's industrial landscape depends on what we choose to do together. Ladies and gentlemen, Prof. Chair, I now profess that Ghana's industrial future will not be built in silos, but through a bold and unified partnership. This is a clearing call for academia, industry, government, professional bodies, community, and students to hold hands in forging a shared commitment. A commitment to invest in the right structures, to build resilient systems, and to nurture a culture of collaboration. Together, we must close the critical gaps in technical skills, in ethical grounding, and in digital infrastructure and inclusion needed to empower every aspiring engineer. These are the gaps that stand between us and the future defining professionals Ghana need to lead in the fifth industrial revolution and beyond. Enuanom, wonsom, wonsom, na ɔmane bɛyɛ yie a na suhia no ara. Wagadare vas. Thank you.
Please, you may resume your seats. We take the national anthem, the abridged form. Okay, so please let's rise.
Shall we please take the closing prayer? Gracious and everlasting Father, we are indeed grateful for your care and support for a successful inaugural lecture. We thank you for what you have done, is doing, and about to do for this university. Help us, O Lord, to continue to grace our generation with richness in arts and science, to build our nation great and strong. Bless, O Lord, the work of this university and the efforts of all who have been vested with authority to administer the affairs of it with honesty and diligence. We pray for all dignitaries, alumni present, students, the press, and all those who came to grace this occasion for a safe journey back home. And now, may the Lord bless you and keep you. May the Lord cause his face to shine upon you and be gracious to you. The Lord lift up his countenance upon you and give you peace. May his presence continue to be with us all as we depart from the grounds of this inaugural lecture until we meet again. Amen.
Staff, can you please move to seminar room 2? Seminar room 2. The students can go to seminar room 1 for something. Students from TASCO and FIASEC, please wait behind.
What's what type of professor more like? I don't know. What they are remember?
Asampaitsa. Abanyansafuso wɔ mu no wɔnka na asɛmpa. The special guest, please join us right at the foyer at the council chamber. Prof. Simon's guests from Takoradi, please join us at the council chamber.